We've seen how to solve a system of equations when they're both in the form y equals mx plus b. We use the comparison method. When they're both in the standard form like this, we use something called the elimination method. The way it works is to try and take these two equations and cancel out one of the x's or the y's from both of them so that we can just solve for one variable. We end up adding the equations together. So I'm going to try and get rid of the x's in here. The way I'm going to do that is by trying to make these two coefficients the same. Or in fact, I'm going to try and make them opposite. So I'm going to multiply this entire equation by -2, using the distributive property to multiply in. So that I wind up with a new system of equations that's going to be -6x plus 4y equals -24, right? I multiplied -2 times everything. The second equation stays the same. And now I add the two equations together. Because these are opposites, they're going to wind up having a zero term here. I don't even have to write anything. These guys come together as 9y, positive 9y, but you don't have to write anything there. And 51 and 24 subtract, and that's going to give me 27. You divide by the 9, and that gets you the value for y equals 3. And just like in the comparison method, once you have one of the variables, you can replace it into one of the equations to find the other variable. So I'm going to replace it into the original, or I can replace it into the second equation. In fact, I think I'll do that. 6x plus 5y, but now the y is equal to 3 equals 51. And we just solve this. 6x plus 15, bring the 15 over. I'll do the subtraction right here in my head. So that's going to be, well, hopefully I'm going to do it right, 36. And then you divide both sides by 6 to give you the x value. Remember, your answer is an ordered pair. So the trick to this is to make the terms match and be opposites from each other so that when we add them together, it's going to eliminate either the x's or the y's, and then we can find the other value.